I will introduce the next speaker, which is Theresa Kushner, and she's the head of North America Innovation Center, NTT Data, and a data evangelist. And we'll talk about the changing relationship between humans and machines and what it could mean for the social fabric of societies. A warm round of applause, please. Thank you.
Good morning. Thank you very much for inviting me to this conference. I've been so impressed with the first hour or so of this presentation because data has been something I have been dedicated my last 25 years to, so I was very happy to hear what Jim had to say about that. And then the climate change and what's happening, that's also something else that we need to take into consideration. All of this comes together with two things that I heard. Data is important, and computing power has got to be there. So that sort of brings me to what I do at the North America Innovation Center for NTT. Someone asked me a couple of weeks ago what my job was, and I said, I play with the future. I thought that was pretty cool. So what I do in the North American Innovation Center is I combine with 5 other centers across the world to bring innovation to NTT. I don't know if you know this or not, but NTT spends over $4 billion a year in innovative tasks, inventing brand new things for the world. Problem is that a lot of those innovations, like the Xerox lab before it and IBM research, never saw it to the point where a customer could use it. We never did a whole lot with it to make it part of our very fabric of our being. So in July of this year, we set up the Innovation Hub, Global Innovation Hub, which consists of 6 facilities worldwide. Each of us was assigned a task. What areas were we going to concentrate on? And then the most important thing, and the thing I'm proudest of, is that whatever we decide to do in one center gets shared with the other 5 centers. So that if we develop something in Europe around digital twin, China will pick it up and use it somewhere in their involvements around metaverse or what they're doing in China. Each of those centers has a directive. My directive for North America is very simple. Develop the digital human, develop everything digitized around a human being. Now, that means that there's this other thing out there in the world called a robot. And robots have been around for a very long time, but what we do with robots in a social environment is becoming more and more important. So today I'm going to talk to you a little bit about, and just sort of tweak your thinking about what social robots can do in our environment, why they're important, and what we need to think about them. Now, here's a question for you, and I can't quite see everyone, so I'm assuming you'll raise your hand and be honest. How many of you have a robot in your home today? Okay, a couple of you, because I will bet you what you recognize is that your Roomba is a robot. So we do have them, and they are there, but in the world of providing actual human interaction, you don't talk to your Roomba, unless you want to kick it when it gets the wrong kind of space in your house. But the robots that we're talking about are those that can provide comfort to Americans, or to anyone, to the world. Our idea of a robot is born of what fiction has told us about robots. Okay. Now, this is sort of a question answer for all of you guys out there. Rosie the robot? Absolutely. She had a prime directive to serve the Jetsons. She didn't do it very well, as I recall, but she had a prime directive. R2-D2 and CP3O, their prime directive was to protect Princess Leia and the Empire. Remember that one? Robbie the robot, his whole entire prime directive was, danger, 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 Will Robinson. So that wasn't a very sophisticated robot. Now, the one on this page that doesn't look like a robot, but has actually created more kind of involvement with humans, is the one at the top. That happens to be Hal, which is really just a transgendered version of Alexa and Siri. It is the heart and soul of the system for 2001 Space Odyssey. And even though he didn't quite protect the way he should have, that was his prime directive. Now, there are today lots of robots that are doing exactly what Rosie and Robbie and all the others were supposed to do, to take care of human beings. And these are out there and available. Jibo sits in my office. Jibo was developed by NTT with MIT in conjunction with MIT to be sort of an educational communicator to children. That's what it did best. And today, what we're seeing is that it's being used in hospitals where children will speak to a doctor through Jibo when they may not talk to anyone else. And that's giving us some inputs. Pepper, developed by SoftBank in Japan, is actually a humanoid robot. Pepper sits in my office, scares the bejesus out of me when she comes in one day and she's automated. My team is right now trying to figure out how to reprogram Pepper to do things around our innovation center. Moxie? Moxie's a kind of an unusual one. You can buy Moxie today for less than $1,000. You can put it in your home with your child, and they can begin to learn from Moxie. They can have an interaction with Moxie. They can actually have Moxie become, quote, their friend. So Moxie is already out there and available. And then finally, Sofa, which is a robot, a home robot from Japan, actually has been developed to allow us to deliver medications to older human beings, okay? So if we have all of this capability out there, why then do we not just see an incredible number of robots everywhere? Why isn't there one sitting in this audience or standing at the door or helping us do something in another part of this building? There are lots of reasons for it, but as we're seeing, we're developing the technologies that will come into these robots in the next 5 to 10 years. And that's kind of what we want to talk about today, is what the possibilities are with social robots. And I want to explore it in 4 different ways. I want to look at what social robots are versus non-social robots. Because that Roomba, let's face it, that Roomba is basically just a non-social robot. Why should we, I'm going to step over here a second. Why should social robots be important at all? Why should we even be talking about them, okay? What obstacles lie ahead of us with deploying social robots, and how do we get ready to take advantage of their capability? Because in some ways, I'm sure we're not all ready to have a robot sit down beside us and interpret what's happening in our environment and help us make it through the day. Although I'd like that every once in a while, I'm not sure I'm ready for that kind of interaction. So, that was wrong. So let's talk a little bit about what the difference is between a social and a non-social robot. Social robots are designed to interact with humans. That means they have to be able to read what a human being is saying in their face, in their voice, in the words that they use. And they have to be able to react to it in some way that is reasonable with the human they are interacting with. That's what a social robot does. Now, non-social robots have tasks they have to perform. And we see them all over the place. We see them in manufacturing lines. We see them in Amazon warehouses. We see them in operating and surgical rooms. Non-social robots do a lot of tasks that where you need precision and you need consistency in that precision, robots are perfect for. Now, that doesn't mean that there's not a combination of these. In fact, what we are seeing is that in some cases, we even have social robots that are directing other robots. MIT recently finished a research project where they had robots directing robots into a search and rescue mission. making sure that all the robots that were involved were coordinated, that they didn't interfere with the drones that were involved, that they actually had some reason for being on the field, and they were reporting back consistently. That's important, and that may be a social part of robots that we haven't even thought about before, their own interaction with each other. Now, you see in the non-social robots, you've got the operating room robots, you have the industrial manufacturing, but you also have the Army. The Army has a huge number of robots that have been designed to take on warfare in all kinds of places. That's what they're used for in some instances. Even Elon Musk has developed a robonaut that will go into space in his next mission. So they're all there. What we do and how we use them becomes another part of what we deal with in our fabric. So let's talk a little bit about why should social robots be important to us today? Because this is sort of at a juncture where we're going to decide how these robots are going to be deployed in our own environments. And it's going to be really, really important to us. So I looked at everything that we might think of as a reason for why robots would be important, especially social robots. And I'm picturing here Sophia. Just so you know, Sophia was developed by the Hanson Labs out of Singapore in 2016. That means she's about 7 years old, okay? She is considered the most realistic robot on the face of the earth today. Now, in this picture, she is not wearing hair. I'm going to show you another picture later where she does, which will really kind of freak you out. Sophia has all of the artificial intelligence that we can bring to bear on this kind of robot today. And to combat the things that we have in our society, it's going to be very important that we have all the data we can have. That's why I was so excited about the first presentation, because at the heart of all of these new inventions is data. We have to have it in order to make wise decisions, in order to have our robots act for us in the way that we would want them to act as human beings. Let's talk about the number one reason it might be important. Robots, social robots especially, do provide a certain amount of comfort, interaction with human beings. And that helps to alleviate something that has become a national pandemic for us in the US, if not the world. Cigna reported in 2020 that 61% of all Americans were lonely, were suffering from loneliness. Harvard followed that up the year after to say that 35% of all Americans were, but that 61% of young people and 51% of mothers of young children were seriously lonely. Lonely to the point of taking their own lives, lonely to the point of, doing terrible things like gunning down 10 children in a school. These people are lonely. And if we can provide some sort of capability through a robot to help alleviate some of that or mitigate some of that loneliness, what a great world that would be. The other factor is aging, and I love this one. In 2012, there were 43 million people in the US who were over the age of 65. By 2030, there'll be double that number. And as we get older, we're living longer too. And what we're trying to do with some of the robot capability we have is alleviate or mitigate some of that aging, helping old people remember things that they couldn't remember before, helping the elderly manage their medications, helping the elderly with tasks around their house. This is a huge effort that social robots are the best to perform. The other thing that's wonderful, and the place where robots get their first little nose under the tent, is with the service economy. The Fortune 500 today is more than 50% companies that provide services to people. Not companies that manufacture things, but companies that provide services. in that service economy, we need more and more people to service more and more things. Robots have begun to fill in some of those spaces where service can be provided by a robot. You see it all the time with chatbots that happen online. That is a form of a robot that is responding to you in a way that it knows you will appreciate as a human being. That service economy is going to press us to do even more. Environmental concerns. Now, although this may not be one handled by a social robot, it will be handled by other robots. For example, it was wonderful, the presentation before, talking about gathering data that they needed in order to be able to make the predictions, or more importantly, just to make projections. What we have seen is that the Swiss robotics labs have developed a robot that actually goes into water and can tell you the pollution count, can manage the way an eel or a lamprey does to collect information. Sending those robots into those kinds of environments will only help us in the end to figure out exactly what we can do as human beings to counter the environmental issues that we have. Physical security for a robot, I gotta tell you, with a great big Robbie the Robot accompanying me home from work at night, I might feel a little bit more comfortable than I would if I had no one at all. So physical security has become something that robots are really good at. Now, the social part of that is you get a really nice physical guard that will respond to you and not shoot you immediately. He'll actually ask you what you might need to know in order to get past this particular location. So the social robots are the kinds that we want to put in place to handle some of these jobs. And then finally, robots of all kinds do dangerous and non-inspiring jobs. One of the things that we've seen with our digital human work is that digital humans can do all of the tasks that we used to assign to receptionists or people that manage very repetitive tasks. Those are the tasks that social robots are beginning to take over. Now, interestingly enough, they won't take over all of those tasks immediately. They're going to take over some white-collar as well as some blue-collar kinds of jobs. And that's going to be sort of something we're going to have to contend with as a society. So, these are very important reasons why we should be looking at robots. But we're not making as much progress as we should. And here's the reason why. It has one thing to do with what was mentioned earlier, with computing power. One of our innovation centers at NTT is dedicated to quantum computing and what we can do in that arena to move that capability into things like robots. Now, interestingly enough, Gartner does not put robots on its hype scale. I thought that was very interesting, that robots was not something that we're going to invest in. But what you will see on Gartner's hype scale are lots of capabilities and technologies that feed into a robot. So if our end result is to put a digital human being in place, physically looks like us, acts like us, and responds like us, then the best thing that we can do as technologists is develop all of those technologies that go into making that digital human. And that's what we're doing, is that you're seeing a lot of high-tech companies invest in things like facial recognition, voice recognition, the capability to predict decision intelligence, which is another very big area that we're going to have to delve deeper into if robots are going to help us make decisions. Because quite frankly, decision making is not just a black and white and read the facts. There's a human element to it that we have to teach our robots and all of our digital humans to manage. So, I don't know how to control this on this particular thing, but this is a representation of a digital human that we have in our facilities in Japan. It basically is in the cafeteria, and in this particular demonstration, she responds to some people about what is available on the menu today, how much does it cost, and how do I pay for it? And she answers all of those questions by looking at the person who's standing in front of her, actually hearing what they say, microphones to pick up that hearing and detect it, and then to respond to it in a way that is appropriate for that human being. This is the kind of work that's going on behind all of the technology that's responsible for creating a robot of any kind. So what we would like to make sure happens is that in our work in the North American Center, where we deal with digital humans, we want to make sure that this is something that everyone can take advantage of. Right now, we have a digital human in the lab that is created from some of our capabilities working with SAP and IBM Watson. What we'd like to do is to be able to create that same capability in an open source so that more people can take advantage of it, so that the collaboration across the world can be much more extensive, and we can actually get social robots that do things in places that we need them to be in today. Now, so if that's so wonderful, and we're creating all this great stuff around social robots, what are the obstacles that we should be thinking about? Here we go. This is your reintroduction to Sophia, now with hair. Now, what do you think about that? Especially if she were sitting down next to you. Wouldn't that be just a little strange? You know, and I've seen her before, so I'm telling you, it is very strange. And that is one of the biggest obstacles that we have to overcome with social robots, because people they'll understand a Jibo or a Pepper or any of those other robots I showed you before, that they got. But the more that robot starts to look like us, act like us, and do things we would do, the more we hit something called the uncanny valley, which is where we get a little freaked out. And our reactions then to robots become different. We don't react the same way that we did when we thought it was doing us a favor and helping support us. Now, all of a sudden, we assign to it traits, human traits, of, oh my goodness, did she really mean that? Or is she double-crossing me? We start to think too much about what the robot's intentions might be, when the poor robot has no intentions at all. But that's one of the things that we have to look at. One of the biggest obstacles in business is developing a business return on investment for a robot. Now, here's a quick story. In San Francisco, there is a coffee shop in downtown San Francisco run totally by a robot. You order your coffee, it makes your latte, even puts the little swirl on the top of it, delivers it to you, and takes your money through Apple Pay or whatever else is available. That machine costs $33,000. Think about it. How much would baristas in that coffee shop cost you on a yearly basis? Probably a lot more than $33,000. However, that coffee shop also has to hire on retainer a $250,000 a year robotics engineer. Now, the entire equation for how we figure return on investment changes, and we have to look at different things. Who are we displacing? What kinds of support does a robot need? Those are the kinds of things that we're going to have to consider with new return on investment cases. And as my husband pointed out when I was doing this presentation the other day, returns on investment don't always have to be in hard dollars. He doesn't work in a business, and so I took that for granted that that's probably true. It doesn't always have to be hard dollars. It could be just in helping children, for example, make sure that they understand how to read for the first time. You know, how valuable is that? Maybe you can't assign a dollar sign to it. But in business, we always look for how much are we going to save, or how much value is it going to create for the business. Technology itself has some limitations. If you read this presentation and you look through the slide where I showed you Mia, who is our digital human, you will notice that there is a delay in her answer. Quite frankly, that's a big deal, because computing power has got to be strong enough to do real-time interactions with people. You can't just ask a question and then wait 5 minutes for the robot or the digital human to respond. It needs to be instantaneous. And some of the capability for that is yet to come. That's what we're looking for in this new wave of computing power that we have. Also, there are deployment considerations for robots. When you get full-bodied robots, social, any kind of robot in your environment, not all of them have learned to navigate things like stairs. And when you put one in the home, you have to have someone in the home who understands robots enough to be able to fix them when they fail. To me, even with Google and with Alexa, we have to reset her every once in a while because she doesn't do all of the answers. She doesn't answer the way we would want her to. So you have to have people who understand the technology. There is also laws and societal regulations that we haven't considered. And I was so excited about the first presentation around data governance because that to me has been my dedicated life for the last 10 years, is how are we going to manage data and what kinds of things are we going to do. But with robots, here's an example. When you have a lot of robots in a job environment, do they pay Social Security taxes? Do they pay taxes of any kind? And if they do, how do they do that? Here's a real live example. When I was at Dell, we deployed bots to take care of some of our service capabilities. Every bot that we deployed had to have an employee number because they couldn't access the systems that they needed to access if they didn't have an employee number. Now, imagine what happens when you're in HR and all of a sudden your employee count goes from 10 to 10,000. What on earth are you thinking? And how do you now sift through an employee number that represents a real human and an employee number that represents a robot of some sort? Those are the kinds of implications that we're going to have. You also have things like insurance. I was at breakfast this morning only to learn that Waterloo in this area is one of the places where you have lots of insurance companies. Insurance companies are going to be insuring self-driving cars. When they do, who's at fault? The car? The owner? What happens in an insurance case if a car hits someone or hits another car? What kinds of things are we going to allow or not allow in our insurance environment? And with robots too, if your robot gets into a fight with another robot, how is that going to be managed? So there are lots of things we haven't considered yet about what we do. And there are also ethical concerns. There's the great divide between all the information that we have and the economies around information and the people that don't have that information and the economies that they don't have. Data at the heart of it is used for everything that a robot does, from its artificial intelligence to how it moves its arms to how it responds. How we collect that data, how we manage that data, and how we ensure that it is not biased in any way is going to be at the heart of what we do with robots and anything in the future. And then there are always those unintended consequences, like, for example, having the HR guys sift through 1,000 names that don't have real people attached to them or numbers for employees. Those unintentional consequences, we don't know yet. That's sort of like we have to go in with the best intentions and hope that the consequences are not dire. So, how do we get ready for social robots? Are we really ready for them to take part in our lives, to be part of what we do? I think that the first thing that everyone needs to do is understand a robot's capabilities and its limitations. You need to know what it can do, but more importantly, you need to know what it can't do so that your expectations are driven appropriately for each robot that's deployed in any environment, whether it's in your work, your business, whether it's at education with your children, you need to understand it. And then there is the look for applications to apply robots for the good. I think we can always use our imaginations and pick out all of the bad things that a robot could do, but why not look for all of the wonderful things that a robot might be able to manage if it had enough knowledge and it had enough people behind it to support it? We need to look for applications for good. And we also need to prepare ourselves for that uncanny valley. Sophia is only going to get better. And she's going to be able to walk around and she's going to be able to interact with you. When you meet her in the hallway, what's your reaction going to be? You know, this is a sort of a new kind of diversity we might have to learn to live with, the diversity of digital humans versus normal humans. So I do think that we need to prepare ourselves for the uncanny valley. The other thing that I would suggest is that we work to design things in government that make sense. I'm very, very disappointed in the United States for its actions around the governance of artificial intelligence. There's only one paragraph of around 200 words that talks about artificial intelligence in the 200-page bill that passed earlier in Biden's administration for the defense bill. One paragraph, 200 pages that talk about artificial intelligence and how it should be managed. That's it. We should have the same sort of regulations, at least in the US, that they have in Europe for how we should manage artificial intelligence. Governing the data is part of it, but also governing the algorithms and what the algorithms do. Transparency to those algorithms is most important. And then finally, we need to become a true citizen of a digital world. I know everybody's got an iPhone, everybody's got something digital in their life, but how much are you immersed in it, and how does it really affect your life? And digital is going to be here. We're going to have digital representations of human beings. Let's make sure that we develop the right kind of way of looking at digital humans. And then finally, our children will be the ones that pick up on it first. This particular robot is helping a little boy do his exercises in a rehab facility. That's the kind of digital comfort we need in this world. Thank you very much.
Thank you so much. This was absolutely phenomenal, and I'm so happy you brought up so many of the points that I didn't highlight at the beginning, which is that technology is a tool. It's not inherently evil or good or supposed to do something that's against what we believe or anything like that. It's mathematics. It's a bunch of algorithms. So it's really up to us how we use these tools and how we design them and what we want to use them for. So this is a really important message for this symposium, is to talk about things about how we create them, how we use them, rather than to be against technology generally, just because maybe we don't understand it or because we're faced with a lot of messages around the world that it might be bad or good, when really it's mathematics.